This is video number 7 on the topic motion in a straight line and third on differentiation. Timestamps are given in the description box. You can watch parts of video if you are running short of time. In this video, I will discuss chain rule of derivatives. Previously, we have studied how to find derivatives of simple functions, like for example, d by dx of a simple function like sin x. Derivative of this function is cos x. This can be derived from the first principles. And we also know the derivative of the simple function x square with respect to x as 2x. Now suppose I want to find a derivative of a complicated function like sin x square with respect to x. How to find this derivative? Say using these two. X is a variable, that is the value of x is changing. When x is a variable, x square is also a variable because the value of x square will also change. So I can call this x square as a new variable u. D by dx of sin x is cos x. Similarly, d by du of sin u is cos u. D by du of sin u will be cos u because instead of x, we change the variable to u. But what we have here is d by dx of sin u. So what we have to do is, this can be written as d by du of sin u, where u is x square, into du by dx. Du and du will cancel and this will be same as this one. So this is the first one, is cos u, and the second one is d by dx of u, which is x square, so that is 2x. So we get the result that the derivative of sin x square is, and u we can replace it as cos x square into 2x. So derivative of sin x square is cos x square into 2x. So here the differential d by dx is done in sequence of two derivatives or chain of two derivatives. So this is basically chain rule of differentiation. So in general, the function can be complicated like this. We have to find the derivative of this function f of x raised to the power n with respect to x. So you have to do a substitution. We call f of x as u. X is a variable, so f of x is also a variable in the sense the value of f of x will change when x value changes. So we can define a new variable as f of x. So this will become u raised to the power n. So we know the derivative of u raised to the power n with respect to u. So this we can write as d by du of u raised to the power n, and to get this dx, how to do du by dx. This is chain rule of derivative. This is same as this because du and du will cancel, and d by dx of this is same as this one. With this, and d by du of u raised to the power n is u into u raised to the power n minus 1, n into u raised to the power n minus 1, because derivative of x raised to the power n is n into x raised to the power n minus 1. So instead of x, we have the variable as u. And du by dx is nothing but derivative of f of x with respect to x, which is f dash x. Another way this function can get complicated is, this is a nested function. First, x is operated by this function g, and the result is operated by the function f. So this also we can simplify by making the substitution g of x as a new variable u. X is a variable, so when x value changes, g of x value will also change. So g of x is also a variable, and let me call it u. So this I can write as d by du of f of u into du by dx. Du and du will cancel, so I'll get this one. And d by du of f of u is f dash u. If f is a simple function, this should be known. And du by dx is nothing but g dash x. Because u is g of x, d by dx of g of x is g dash x. So this is the way to find derivatives of complex functions using chain rule of derivatives. Like d by dx is nothing but d by du into du by dx. Another way of defining the function is x is a function of t, some gt, and y is also another function of t, f of t, and we have to find dy by dx. So this thing means when t changes, value of x will change according to this relation, and when t changes, y will change according to this y equal to f of t. So from this we can calculate when x changes, y will also change, because when x changes, t will change, because x equal to g of t means both x and t are related. So when t changes, x changes. We can also say when x changes, t will change. So when x changes, t will change, and when t changes, y will change. That means we can conclude that x changes means y will change. So x and y are related, so we can define a quantity dy by dx. But from these two definitions, what I will know is dy by dt is known because f will be given as f dash t, and then dx by dt is also known using this one as g dash t. From this I have to find out dy by dx. So dy by dx can be written as dy by dt by dx by dt, because dt will cancel and give this one. So this is another way of applying this chain rule. To find dy by dx, I just find dy by dt and dx by dt and divide them to get dy by dx. So we may solve some examples. So we know derivative of sine x, but here what is given as sine x square. So if you make the substitution x square equal to u, I know d by du of sine u. But what I have to find is dy by dx, and there is d by dx of sine x square. If you make this substitution, this will become sine u, but d by dx I can write as d by du into du by dx, which is chain rule of derivative. This is known as cos u, and du by dx, u is x square, so it's 2x. So it's cos x square into 2x. So these are the chain rules applied to get the derivative of a complicated function like sine x square. Next example, we have to find derivative of cos of log of x. We know derivative of cos u, or also derivative of log x. So here we have to make the substitution log x equal to u, because u is a variable and x is a variable, and du by dx can be written as d by dx of y can be written as d by du of y into du by dx. Du will cancel to give this one. And y is nothing but cos u. Derivative of cos u is minus sin u, because derivative of cos x is minus sin x, into du by dx, which is derivative of log x with respect to x, which is 1 by x. And you have to substitute u. So minus sin u is log x into this logarithm is to the base e. By default, it is base e. So this is the answer for this derivative. Third example, x is a function of time t and y is also a function of t, but you have to find du by dx. So here du by dx can be written as du by dt by dx by dt, because dt will cancel due this one. Du by dt and dt dx by dt are known. Derivative of sin is cos t and derivative of cos is minus sin. It's minus cot t. Here x is known as a function of time and y is known as a function of time. So to get du by dx, we can do this one. Another way is, can we get the relation between x and y by eliminating t? So there is, in this particular example, there is simply way of eliminating t between x and y, which you have to square and add them. So if you do that, you get x square plus y square equal to cos square plus sin square, which is 1. Now we can differentiate this one with respect to x. So this will give me 2x plus 2y into du by dx equal to 0, because derivative of constant is 0. 2 will be cancelled. So du by dx equal to minus x by y, which is minus cot, which is same as this one. So this is possible because in this case, it's a simple example. There is a way to eliminate the time and get the relation between x and y as this one. But this is applicable in general. In this particular example, this is applicable. So to summarize, derivative of simple functions are known, but to find derivative of complex functions, here it's a composite function because x is first being operated by g and then f. So this is composition of functions g and f acting on x. So here we have to make the substitution that g of x some new variable, say u. So this is being f of u. So I can write this as d by du of f of u into du by dx. So d by du of f of u is f dash u, where u is g of x, and then du by dx is nothing but d by dx of g of x, which is g dash s. So this is chain rule because here one differentiation is being converted as sequence of two differentiations with this chain of differentiations. So here it's composition of two functions. It can be generalized to more than two. For example, here it's composition of three functions. First, x is being operated by h, and then g, and then f. So here I can make a substitution h as u, and g acting on u as another variable v, and then this final thing is f of v. So this can be just a d by dx of f of g of u, because u is h of x, and then g of u can call as another variable v. Okay, so this I can write as d by dv of f of v into dv by dx, and dv by dx is nothing but, so this is nothing but f dash u, because derivative function with respect to this parameter or the argument itself is nothing but dash. D by d of v is g of u, and this can be written as d by dx of v can be written as d by du of v into du by dx, and d by du of v is nothing but g of u. So this is nothing but g dash u because it's this derivative with respect to the argument here, and this is also derivative for the argument here, which is u of x, so it's u dash x. So it's become f dash v g dash u into u dash x. So basically d by dx is written as d by dv by dv by du is known, du by dx is known, and then d by dv of the resultant thing can be found out. So here dv and dv will cancel, du and d will cancel, so it will give me d by dx.